to start. So, last class we have seen about your UML diagrams. So let me share the screen. So today we are going to see state chart diagram. So I have already started explaining about state chart diagram. So we will continue with that. In state chart diagram, as I told you, there will be one start state and one end state. Okay, the symbols are here. This is the initial state or the start state symbol, and this is the final state or the end state symbol. Now, here we have example for state chart diagram. So I have given you 2-3 state chart diagram examples already you can see. So initially, before you perform any action, there will be a state called idle state. Okay, so initially, before you perform any action, there will be an initial state which is known as idle state. So this is what you have seen here, initial state of the object. Now sending order request. So if the request is special or normal, accordingly you have to proceed with the actions. If it is normal order, then get the order, confirm the order, those things, those actions you can add here. So the basic actions I have added here, sending order request, and if the order is special or normal order, order confirmation will be done after the order confirmation, dispatching of the order, and complete transaction. Okay, that means you complete your request. And in case if you order your food or anything incorrectly, then there will be an abnormal exit which leads you to the end of the state. Okay, so from this end of the state, abnormal exit. In case if it is entered incorrectly, sometimes your request can be incorrect, can have incorrect request. Now, coming to the next diagram, activity diagram. So activity diagram is somewhat similar to a state chart diagram, where in activity diagram you have your representation of the flow of the model in the form of a flow chart. So activity diagram is basically a flow chart to represent the flow from one activity to another activity. So you have already learned about drawing a flow chart in your, I think, second year or first year, I think so, in your C programming. So C programming, all of you have learned about C programming. There you have studied about how to draw a flow chart. So the same flow chart representation we are going to utilize here, slightly different. Here we are going to give the names of our actions. So you see here activity diagram for ATM management. So the diagram looks like an ATM. No, sorry. The diagram looks like a flow chart. This is the start state. The symbol shows the start state, inserting the card, entering the pin. Then in flow chart, you can have a decision criteria or the decision symbol, whereas in your state chart, you don't have any decision criteria or decision symbol. Okay, so this is one of the differences of state chart diagram and activity diagram. In state chart diagram, you just explain the flow. Okay, and in activity diagram, you explain the flow along with the conditions applied to the model. For example, if you have an incorrect pin enter, then your system will go back to your inserting the card option. So you can have a loop also here like this. Okay. If the pin is incorrect, then in your state chart, normally we do an abnormal exit. Suppose if you perform any um, incomplete transaction or incomplete incorrect ATM pin and all, then you have an abnormal exit in your state chart diagram. Whereas in your activity diagram, you have a loop. Okay, you have a decision criteria where you have some conditions. So here the condition is if the pin is correct. Okay, you are going to check if the pin is correct or not. So if it is incorrect, then you have to start from inserting the card once again. Okay. So you have a not inserting the card, entering the pin once again. So this arrow should be here. Okay. Now, if the pin is correct, then you can perform your actions, whether it is cash withdrawal, depositing the money. So it is according to the user who is going to perform the actions. So according to this diagram, we have chosen for withdrawing of money. So we are entering the amount here. So you perform the transaction. Then once you complete the transaction, then we can come to the end of this state. Okay, end state. So this is the initial state or start state. This is the final state or end state. This is how we draw activity diagram. So we will see one more. Activity diagram can also be drawn in such a way. Okay, so you all have the order request, then condition criteria. See here, on the right side, you have a condition criteria. If the condition, if the order is normal order or special order like that, you have some conditions here. Okay, so this condition criteria will not be there in your state chart diagram. Okay, so this is the difference between activity and state chart diagram. So next diagram, we will see this is about component diagram. So component, when you say some this word component, so this shows that
Ma'am,
you have
ma'am,
yes,
there are some guys trying to join.
okay, okay. Okay, okay, I have admitted them. So actually, I was about to start the class by 3 o'clock, but I couldn't since I just reached home now from college. We had our department meeting from 12:30, but it started by 1 o'clock. So little late we have started, but anyway, we have very few diagrams left to explain regarding the UML diagrams. So once we finish UML explanation, we will do some exercises next class, and we can start our lab sessions. Now coming to the next diagram, component diagram. So component diagram, these are normally used to model physical aspects of a system. So what are the physical components of the system that we are going to draw using the component diagram? Now, in component diagram, you can see like this. Okay, component diagram for ATM management. So we will study some three component diagrams. The first diagram here, as you have used two classes or three classes accordingly in your ATM management system. So that classes we are going to put here. Okay, so this symbol is represented for component. I think this one it is explained here. Component notation. Okay, component notation. Component is used to represent any part of a system for which the UML diagrams are made. Okay, so component symbol is like this. So that is what we are using here. Okay, so bank, ATM control, ATM user interface. So we have three classes here: ATM user, which is going to communicate with the ATM machine, and ATM machine, they are going to communicate with the server, okay, bank server. So we have three components here in our ATM management diagram. So ATM management model. So this same model also can be drawn in such a way. Here we have drawn using three classes: ATM user, which is the customer or the client, and ATM console, this is ATM machine, and bank, this is the server or admin people. Okay, that one. So we have three components here. So here also we have three components: client, ATM, and deposit amount. The deposit amount is nothing but your admin or the bank server, where we have to perform certain transactions virtually. Okay, that is component. This is also component diagram, and we will see component diagram for order management also. So this represents the symbol what you have seen here. This is known as Java files. So if your files are stored in using any programming languages, that file names you can put here. If it's C++ files, you can write here C++ files. So here also you see customer is one object or one class which we have used, and order is also one class which we have used, where order has two subclasses: special order and normal order. So that is written here. That is written here. Okay. So customer.java, this is a file name. Okay, customer.java, this is a file name. This is also another, order is also another file name. Normal.java, this is also one file name. Special, this is also one file name. So customer, order, special order, normal order. These are components of order management system. These are components of order management system. So the customer is going to communicate with this order class, and this order class again has two subclasses: normal order and special order. So you can also draw component diagram in this format. Okay. So I have explained two formats here where you can draw component diagrams in the form of files or in the form of components. In the form of components, the representation looks like this. In the form of file, the representation looks like this. So any of the forms you can draw. Next diagram, this is the last diagram, which is known as the deployment diagram. Deployment diagram. So these diagrams are normally used in order to visualize all the physical components of the system. So whatever the physical components or software components, whatever responsible for developing that particular model, that will be visualized in this deployment diagram. Okay, one second. Deployment diagram. These diagrams, as I told you, they are going to visualize the overall components of the system, whether the physical components or where the software components are deployed. They are going to be visualized in a deployment diagram. So we will see deployment diagram of ATM machine, and ATM machine. This is for ATM machine, okay, not for ATM management, not for ATM management. ATM management also we will see. Now first let us see the deployment diagram for ATM machine. So where you have One second, one second. Okay. So in deployment diagram for ATM machine, so ATM machine can have ATM server and user account server. So we are deploying this particular ATM machine into two different objects. Okay, one is ATM monitoring server and user account server. Okay, so this system we have deployed into sub parts where ATM machine can have ATM monitoring server and also user account server. And we will see another example. So deployment diagram for hospital management. Suppose when you draw a deployment diagram for hospital management, as I told you in deployment diagram, you are going to visualize all the physical components and also the software components. So hospital server, local server, this is the main thing which we have printer which is connected to the server, and we have a database for the employees or for the patient people. So this is connected to the server, and desktop client, this is for the customer. Okay, customer or the patient who are coming, that will be connected with the hospital authority, and the hospital authority, they are linked with other components or other uh, like printer, like database server. So these are connected with the hospital local server. So overall, this can we by seeing this diagram, we can see that once if a customer comes to the hospital, this customer will be providing some details to this hospital authority, and this server which is connected to the printer and also which is having another network that contains the database of the hospital, maybe for the employees, maybe for the patients, like that, maybe for the medicines. So a deployment diagram can also be drawn in this format. And also we will see one more example where we show all the components of the particular model. So for order management. So by seeing this diagram, I think we can easily understand from this what is a deployment diagram. So user, the person who is going to give the order. Now, when we give an order management, we are going to give through a medium. Okay, so a computer will be there, a modem will be there, which is connected to the internet, and this internet has this particular servers. Server 1, server 2, server 3, maybe different kinds of servers. It can have according to the network of this particular order management system. So a user is going to connect to the order management, or is going to connect with the particular food order authority with through this medium. Okay, so the user will be using a computer which is connected to an internet. Then the internet may be connected to different servers. So this shows all the physical components and also the software components. Okay, so this diagram represents deployment diagram. So when you take in your internet, you can have certain types of diagrams. So you can follow which one is easiest to you. Okay, but deployment diagram, it will show the system, it will show the components of the system. Components in the sense, whether it may be physical components or whether it may be software components. So the overall system will be deployed in the form of diagram. Okay. So this is deployment. Where in component we are going to show, we are going to visualize only the what? Physical aspects or physical components of the system. We are going to visualize only the physical components and we will show the relationship between the components. Okay, that is component diagram. So once again, let me go through from the beginning and we will discuss some examples on it. So UML, Unified Modeling Language. So this part is very important because even in your Viva also, I'm going to ask about your UML. What is UML? What is the full form of UML? How are we going to use this UML? In every semester, every student, they used to forget about this the definition of UML, the abbreviation of UML. So just be careful in reading this one. UML stands for Unified Modeling Language, and this is a standard language we use for visualizing and for constructing, documenting the artifacts of software systems. And also it is the pictorial language representation used to make for software blueprints. Okay, so these are the diagrams, normally 8 diagrams. There's 8 diagrams. It comes under these categories. We have class diagram, we have use case diagram, we have behavioral diagram. In behavioral, we have 3 types: interaction, state chart diagram, activity diagram. So sometimes I may ask you, state chart diagram comes under which kind of diagram? So in that case, you have to say behavioral diagram. Okay, an activity diagram. Again, in interaction, we have 2 more diagrams here under interaction: sequence diagram and collaboration diagram. Okay, and finally, implementation. Implementation part is how the actual system is implemented. So this diagram, we have another 2 types: component and deployment. Somewhat similar, slightly different. In component, we show only the physical aspects of the system, while in deployment, we show the physical aspects along with the software components. Okay. Then class diagram, you can see here we have already discussed 3 sections will be there: class name, attributes, and operations. So class name is based, sorry, attributes and operations are based on the class name you have given. So when I say attributes of a particular class name, you have to say the features of that particular class. Okay, so class diagram, where is it? Here. Class diagram, 3 important sections. So name, roll number, section, these are all the features of student class. Okay, student can have this particular features. So attribute, number of attributes depends on you. That means the one who's going to construct the diagrams, because you can have more number of attributes or lesser number of attributes based on how you understood the system, how you understood the scenario. Okay, and even the operations are also same. Operations also you can have more number of operations. So how you interpret the system, how you understood the system, so based on that your operations can have more number of operations. Okay, but a class diagram should have these 3 sections mainly. And these are extra components. Even here it is written this is not mandatory, which means we can have this component as an extra, otherwise we can exclude this component. But in most of the diagrams, when we draw in your lab, or when you check in your internet, you will be seeing only the first 3 sections. So diagram here already explained, and there will be a mapping here in between the communication link, this N to 1, which means many to 1. There are some three types of mapping, I think: one to one mapping, many to one mapping, and one to many mapping. Many to many also. So four types of mappings are there. So accordingly, you have to choose the suitable mapping. So sometimes um, this mapping may be different for some kind of other models. So it is based on the question given, and also the scenario, how you understood the thing. Okay, so mapping also can be different for some other, like one user and one student. When you construct this, sometimes your mapping can be one to one mapping, like that, and sometimes other students can write many to one mapping also. So that depends on the question given. You have to read the question very carefully, and you should not make any mistake while drawing the diagram. So order management, we have already seen this: customer order, and this is a generalization symbol. Generalization symbol, it is again explained here. This is a relationship between a general class or use case or a more specific class. Okay, so this is the main class vehicle. If you consider vehicle is a main specific class, we can have bus as one vehicle, truck as one vehicle, car as one vehicle. Okay, so this is called generalization. Now coming to this diagram, so we have two important classes here, or two main classes here, and special order and normal order. They are the generalized class or derived class. Now use case. Use case is very important among all the diagrams. Okay, once you understood the use case diagram properly, then all diagrams you can construct very easily. So use case diagram, we have important two symbols here in use case. One is the actor symbol and the other one is the use case symbol. The actor symbol, it identifies the user. That means user in the sense the one who is going to perform some action. The one who is going to perform some action. That is known as actor. Actor is what? The particular person or the particular system who's going to perform some actions. And use case symbol, it is represented with this symbol like this. Now use case, we have two actors for ATM management. One is the client who is going to uh, perform some actions after coming to the ATM machine board, and this is the admin. You can consider as admin that's going to interact with the user, with this user. So a user can perform certain operations here that has been listed down here, like inserting the card, entering the PIN. These are some actions a user can perform: inserting the card, entering the PIN, entering amount. This entering amount is based on the options that this particular user has chosen. Okay, so this is the communication link or association link. We can say client or the user is associated with inserting the card operation, like this. And ATM machine or ATM admin is associated with reading card use case, like this we can say. Okay, so now coming to the interaction diagram, sequence diagram, collaboration diagram. Sequence diagram, this shows how the system interaction is done between the system and the environment in time sequence. Okay, so we have vertical representation, we have horizontal representation. Vertical representation shows the time, horizontal representation shows the objects, and there will be a message written in this symbol, event. You can see your event. Here you are going to write the message. The class 1, class 2 are nothing but the classes which you have used while drawing your class diagram. So diagrams we have seen, 3-4 diagrams we have seen. This is with 4 classes, this is with 3 classes, again this is with 3 classes. And since we have special order and normal order in case of order management, that can be drawn in such a way. So vertical, this one, vertical pole represents the time, and message is what, like sending order, returning. This is response. Bringing back some response, we can draw with this symbol. And also in collaboration, the main difference is in collaboration, you have numbering system. Okay, numbering is very important. The message, whatever is carried out between the two objects, there will be a numbering. So this is also one kind of interaction diagram where it shows the order of messages that implement an operation or transaction. Okay, so communication will be done between the classes and numbering will be there. So numbering 3 diagrams I have told you, where we have more number of operations here in ATM management. So, and this is the easiest collaboration diagram according to me. But if you understand any of this, you can use while drawing in your lab. But normally we prefer this one. So as soon as you see like this, you can easily understand this is a collaboration diagram. Okay, so sending the order, confirming the order, dispatching the order are the operations. And we have the classes here: customer order, if it is special order or not. If it is normal order, you will be writing instead of special order, normal order. And state chart, say here there are 2 important symbols: initial state symbol and final state symbol. And state chart diagram is drawn in such a way. So the initial state before you perform any action is known as the idle state. So others remains the same. An activity diagram is just like your flow chart. How to draw a flow chart in your C programming, you have already learned regarding this. So the same concept we are applying here. So the main difference between activity diagram and state chart diagram is, in activity diagram you can have decision criteria, whereas in state chart diagram you don't have any decision criteria. Okay. So component component diagram, as I told you, this represents the physical aspects of the system. You are going to visualize the physical components. While in deployment diagram, you can explore not only the physical components but also the software components. So this is all about your unified modeling language. So as an assignment, let me give you some examples on how to draw other remaining UML diagrams. We have just seen drawing UML. I have just sent you assignment last week regarding class diagram. So this week I will be sending you assignments for remaining other diagrams. So can anyone draw a activity diagram for ticket reservation, and can anyone explain regarding this ticket reservation activity diagram? Just you can tell me the steps. Activity diagram for ticket reservation. Activity diagram for ticket reservation. What happened? No one knows activity diagram. Do you know how to draw a flow chart? Do you know how to draw a flow chart? Do you know how to draw a flow chart? Do you know how to draw a flow chart for addition of two numbers?
Yes, ma'am.
Hmm.
Activity diagram for this ticket reservation system.
Yeah,
So,
tell me.
first step would be form submission or
Hmm.
any query regarding any trains.
So this is an online ticket reservation, okay? First you need
Okay.
to log in, right?
Yeah.
First you need to log in into a particular website. You may have some credentials on that.
Then it will check for credentials,
Yes,
whether login credentials are
yes,
right or not.
yes. Then, so in that case, if you take a login credentials, you can add some decision criteria also. Since it is an activity diagram, you can add some
Yes.
to the condition criteria. And after that, if
Yes,
the
ma'am.
condition criteria are correct, then you can choose option.
Then yes. They
Mm,
can. Then we can search for trains,
yes, you can.
whatever trains are available.
Okay, okay. Search for train, book the ticket, make the payment, confirm, confirm the ticket, then end of the state. Right? It is very easy.
Yes.
What happened? 53 students are there and only one is answering when I say activity diagram. It's just like your normal flow chart. I think all of you have already studied about drawing a flow chart. The same concept we are applying here. Just in case how we name the particular symbols and these are little bit different, others remains the same. Simply you are taking from internet and if you are submitting the assignment, it won't be of no use, okay? No use at all. So instead, when I ask something inside the class, please try to answer. Anyways, let me just start another topic. 5 minutes I'll complete. It will take only 5 minutes because this is your next topic. So this, whatever we have studied now, this is regarding UML, Unified Modeling Language. Now we will see what is SRS. Okay, SRS. SRS is nothing but software requirements specification. Software requirements specification. SRS. So SRS is like just like a document. It's like a documentation. When you write a thesis, writing, even now you are in fifth semester, right? So by next semester, you will start your project work. So once you complete your project work, at the end of the completion, what do? You write a documentation of your project work, right? That is called a thesis. You write a thesis at the end of your project completion. So the way how you write a thesis, exactly the same we are going to do in our SRS, software requirement specification. Okay, so let me share the screen. Software, software requirements specification. Okay, so you can just zoom and see. 1 second. Okay, so software requirement specification, it is a document that captures complete description about how the system is expected to perform. Okay, so this is nothing but a document. So how we are going to write a document based on some rules and regulations. So that we are going to study. So here they have explained some qualities of software requirement specification. The qualities are correct. That means you should have a correct document, unambiguous. So that means you should not have your repeated document, a complete document, a consistent document, and it should be ranked for importance and stability, verifiable document, modifiable document, and testable document. So I will just show you the document example. Okay, so theories you just go through by yourself. I will show you the example how a SRS document looks like. So in writing an SRS document, you can see you have to create an outline. Either you can use an SRS template from the internet, or else you have to create an outline. So how to create an outline using this one? Initially, you should have an introduction of your particular model. Suppose if I say hospital management, you write an SRS document of hospital management. Then what you have to do, you have to write an introduction about the hospital. Okay, you have to write an introduction about the hospital. Then what is the purpose of it? You have to explain what is the purpose of it. An intended audience, so you might be having certain patients and certain employees and certain other people related to the hospital, that you have to explain. And what is the intended used, that means what, how, why you have a hospital. So it has certain benefits of a hospital, right? So all those things have to be explained. Just like, for example, in your say in your project work, if you choose a particular project name, developing an Android software, developing an Android application, if you say that is a project for you, then at the end of your project work, you have to write the thesis. So then, in writing the thesis, you have to explain everything about how you develop the Android application. So exactly the same thing we are doing here. Okay. So in that, initially there will be your front page, title page, table of contents. So what will be there? So then your page numbers, then list of figures, list of tables. So everything you have done in writing a thesis for your project. So the same concept is applied in writing an SRS document. That is what it is given here. What are the user needs? What are the overall description? Then we have certain features, system features. What are the functional requirements? What are interface requirements? What are system feature? What are non-functional requirements? So everything you have to explain in the form of document. Okay, that is SRS document. So you have all these things, you just go through once. Definitions and acronyms usually we write in writing a thesis, that also is included here. Why do we include definition and acronyms? In order to define the particular word very easily. Okay. So what is the scope, sorry, what is the scope of your document? What is the Hospital management, I told you just now, hospital management. So what is the scope of hospital management? That has to be explained here. So these are some brief introduction about SRS documentation. So now when I say hospital management SRS documentation, I will just show you an example how to write the hospital management SRS documentation. So this presenting, yeah, this is hospital management SRS documentation. Okay, software requirement specification for hospital management. Now, so this is your front page. So next page number 2, it includes the acknowledgement, like to whom you want to give acknowledgement for this particular work. So acknowledgement, it is listed here. Now table of contents, it is important. Okay, table of contents, acknowledgement, table of contents, revision history, then in introduction. So what is the purpose, intended audience, project scope, references, overall description, it is explained into subsections like this. What are the system features? System features, it is explained here. Then what are the external interface requirements? Software requirements, hardware requirements, communication requirements, user interfaces. They are explained in another section. And next section, we have non-functional requirements that are explained here. And finally, we put in the appendix. Okay. So you can just go through this example, and in next class we will see another example for SRS documentation. Okay, SRS documentation, another example we will see in our next class. Okay, so that's all for today, and for your understanding purpose, SRS is nothing but it is a document. Okay, it is a document where we have certain rules to write that particular documentation. Okay, like how you write a thesis for your project work. Similarly, we are following the concept in writing the SRS document. What are the requirements? What is the scope? What is the overview of your work? Then functional requirements, system requirements, non-functional requirements. So all has to be written in the form of a document. So next class, we will see some more examples on SRS documentation and what is software requirements before we go to the next chapter. Okay. So I think you understood. Just joining just now. You understood regarding UML concept at least something. Did you understand UML diagrams?
Yes, ma'am.
At least some idea you can understand, right? If not all, at
Yes,
least
ma'am.
something, at least
Yes.
something. Okay. So how we draw class diagram, how we draw use case diagram, at least something you understood, right?
Yes, ma'am.
Okay. Okay, so I will consider you understood at least something regarding UML diagrams. So when you start your lab sessions, you will understand more. So we have your software tool, like your Start UML is one software tool, and also we have some other tools which we will be using. But for now, I think your ma'am, Nirvana ma'am, is going to use this tool, Start UML. So using Start UML, we are going to draw all the diagrams. So once you started drawing the diagrams, you will understand this is UML use case diagram, this is class diagram, how these connections are made. You'll understand more. Okay. Anyway, I will take your attendance. So those who gave your attendance, you can leave from the class. Roll number 1,
Present, ma'am.
roll number 2,
Present, ma'am.
roll number 3, roll number 4,
Present.